The following video will explain how to use the normal probability applet in order to calculate p-values in two different ways. In Exploration 1.5, recall our null hypothesis is that 50% of people would call heads, and the alternative is that more than 50% of all people would call heads in a coin toss. Let's use 55 out of 88 as our sample proportion. To use the normal probability calculator, we can either calculate the standard deviation of the sample proportions under the null hypothesis, then compare our observed statistic to the appropriate normal distribution. Remember that normal distribution will be centered at pi, or our null value in a hypothesis test, with standard deviation square root pi times 1 minus pi over n. Or we can calculate the standardized statistic and compare that value to the standard normal distribution, or a normal distribution centered at 0 with standard deviation 1. Let's use the first method first, and then we'll try the second. So here, the center of our null distribution will be 0.5, the null value, and the calculated standard deviation of the null distribution should be 0.0533. Let's head to the applet. Let's go to More RC Applets to get to the normal probability calculator. Fourth down under Probability. If we are simulating the null distribution, or using our normal probability calculator to assume the normal distribution for the null, then our mean would be at the null value, 0.5, with standard deviation 0.50533, which we just calculated. Let's scale that to fit. Then our x value will be our observed statistic, or 55 out of 88, which is 0.625. Remember, our alternative hypothesis was a greater than sign, so I need to change this value, or change the sign here to match the alternative hypothesis. I get a p-value then of 0.0095, or the probability of being greater than our observed statistic under this null distribution is 0.0095. Remember, there was a second method where I could compare my standardized statistic, z, to a standard normal distribution. Well, a standard normal distribution has a mean of 0 and a standard deviation of 1. So let's go back to those values and then calculate our standardized statistic. Remember, our standardized statistic is our p-hat value, 55 out of 88, minus the null value of 0.5, divided by that standard deviation of 0.0533. If I do that, I should get a z standardized statistic of 2.34. Because our standardized statistic is a z value, instead of plugging this in for x, I'll now plug it in for z. 2.345. Again, the alternative hypothesis is a greater than sign, so I need to match the sign in the normal probability calculator to the alternative hypothesis. If I scale this to fit, we can see we get the exact same probability, or the probability of being greater than our standardized statistic under the standard normal distribution is 0.0095, the p-value for this test.